Now the next two programs that I need to introduce are SED and AWK, SED and AWK. We're going to cover SED first, but very often you see SED and AWK used together. Now you might remember from earlier in the program we searched Moby Dick and replaced Ishmael with Roger. So we did that with VI. SED is another way we could have done that. Now suppose that we want to replace the it was the best of times with it was the worst of worst, which is a bit nonsensical. I would say that SED is not exactly the right tool for that, but it is doable. You could do search for best \pipe times /worst/g. And so that'll search for best or worst, or best or times, and replace it with worst. And so normally when you are in a situation where you want to use SED on multiple matches on a single given line, chances are you're probably not going to use SED for that. In this particular case, SED does kind of make sense. It's sort of a rough example. It's hard to come up with related examples unless you already have years of experience doing system administration, and then it's like, oh yeah, this would be really handy if you're looking for users on the system, or if you're looking for who had a print job, or if you're going through the system files or logs or the users files, or looking for something. So it's a little weird when we're just searching through texts that we download from Project Gutenberg. I think that the other side of this that I mentioned at the beginning is called awk. And so what awk does is it will match, for everything that matches, it'll perform a command. And so you can use SED to search for something, and then awk to actually execute a command based on whatever it found. Now, like most of the programs that we're zooming through, SED and awk can have a book written about just them. In fact, I think O'Reilly has a book written on just SED and awk. The thing to understand about awk is that it's really useful for commands that output their information in fields, so that you can say, give me field 2 from the output of this command, which might be a list of files, or might be a list of permissions, or something like that, so that you can do some other operation on them. In our case, we're just going to do awk, and we're just going to print line number 300 from our Moby file with the line numbers. And so there is line 300. The proofreaders of this version are indebted to the University of, let's go for line 3000, because that's probably in the text. Line 3000 is the wharf. As we were only going along, the people stared, not at Queequeg. Oh, there we go. Maybe we want to print line number 3000 to line number 3005. Well, awk will do that for us. Awk nr equal 3000 to nr is equal to 3005. So because awk operates on fields, if we do awk and then quote and then curly bracket print nr $0 on moby10b.txt, this is the one that does not have line numbers, pipe head, so we only care about the first 10 lines. We can see that it's going to number the lines, although this is not nearly as nice as NC was, because remember NC figured out how many lines there were in the file, and so when we had like a 5 or 10 digit number, we had one with a bunch of leading spaces, so everything would line up really nicely. But this is just putting the number 1 and then $0. So maybe if we put, space, colon, quote, space, $0. Okay, that's formatted a little better, but the numbers are still, each longer number is going to format it over a little bit. If you're a programmer, and awk is a little easier to understand if you have a programming background, but we can use printf and format this as a number, and so it'll automatically figure out and do leading zeros. I'm sorry, and it'll automatically figure it out and do leading spaces. Okay, so I've put in a magic string here. So printf %3d %s \n. \n is the new line character on Unix, because otherwise it would be filtered out. See, without the \n, it just kind of displays on one line and it doesn't work. This is because the formatting of this text file is what's called a DOS formatted text file. So this is kind of a side note, but kind of a thing you should remember, because it's going to come back to haunt you a whole bunch. There's DOS style text files and Unix style text files, and it has to do with the line endings. Unix style line endings is just \n. It's a new line character. DOS style line endings or /R/N. So it's a carriage return and a new line. Carriage return was a special character that, like when you were talking about a teletype machine, where the teletype machine would go across, and then when it was done, you would say carriage return, and the carriage would return all the way back to the 0th column, and the new line would advance the head. So think about like a mechanical printer where the print head, or a typewriter where the print head is going across the paper. The carriage returning from the end of the line and a new line being done are different things, because you might type 5 characters and then new line, and then 5 more characters and new line, and 5 more characters and new line. And what that would look like on the printout is some text, and then the text would drop down, and then some more text, and then the text would drop down and some more text. But when you do the carriage return character, the carriage return would go all the way back to the beginning. Well, on Unix, it's just new line. New line automatically sends the cursor back to the beginning of the line, or sends the print head back to the beginning of the line. So because this is a DOS formatted file, I'm going to explicitly tell it that I want the new line character, because /R/N is not interpreted by awk, because it's a DOS style. And we can tell awk that, hey, we're using DOS style endings. There's a utility called DOS to Unix and Unix to DOS, which are not installed by default in these systems, but you can use DOS to Unix or Unix to DOS to convert between the line endings. If you've ever installed Git, and Git is like, do you want Unix style line endings or Windows style line endings? Now you know what that means. So you can see here that this is formatting it with /1, /9 or 10. So I specified %3D. This is a C, like C, C++, really C formatting convention. And we know that it's going to be 21,000 lines or whatever. So we know that we're going to need a lot of leading spaces. So %5D or 6D or 7D. And now that we've got sort of the magic here, it's like, oh, I want the line numbers at the end of the line instead of the beginning of the line. Well, that would be doable as well. We could do %7D to add the line numbers at the end of the file. And so it's like, oh, ran out for this one. That means that there's no other. We can just do an NR again. And it's like, well, we've messed everything up. Now we can see that, you know, it's messed up and the spaces are missing and all this kind of stuff. And it has to do with the DOS style carriage return floating around in there. So for right now, I'm not going to worry about fixing this. So it's just totally fine. Now for awk, if you wanted to break this up and have every word be its own field, you could do that. Although it doesn't really make sense for text, because again, awk is meant for more table formatted output, kind of like ls. Although, you know, really examples that I would give you with ls don't make a lot of sense either, because most real Unix programs will use the find program to find files that are matching a specific thing. So like if you wanted to, you know, reformat this with owner or reformat this in some other way using awk, generally awk is more about running a particular command on something else has matched, or formatting a report, or, you know, doing something for programmery stuff. It's not really meant for like taking the output of ls and reformatting it. That might have been true at one point in Unix's history, but I don't think that's really true anymore. So in terms of certification, how does sed and awk and WC, and how does all this fit together? Well, you know, as we've gone through Moby Dick, we've had some really simple things that we've done. We've added some line numbers, we've manipulated it. This is really the extent of what you're going to see on your introductory, you know, Linux certification exam. There's a couple more things that we need to do that are things that are likely to come up, but it has to do more with regular expressions and maybe a little bit with sed. So as we've gone through this, you know, we've got the Gutenberg text at the beginning of this, and it's like, okay, yeah, blah, blah, blah. And, you know, maybe we want to, do this a little differently. So, you know, where does the text actually begin? So it begins with "Call me Ishmael," but there's this prologue here, Moby Dick or the Whale. Notes on this e-text. This is a combination of e-texts, one page from now defunct Eris, Project Virginia, and then Project Gutenberg's, you know, there's proofreaders. This e-text was prepared by some people, you know, in the small print for public domain e-text. So 284, there's 284 lines of nonsense in this, and really maybe more like 306 lines, depending on how you want to, in chapters 24, 89, and 90, you substitute L for the symbol of British pound. So let's just let's get rid of the first 311 lines. So we can use sed for that. So we could example sed command, which you should be able to, like if you want, you can pause it now and try to come up with a command on your own using the man command, and research, like do some reading, that kind of thing. So to get rid of lines 1 through 311, we can do sed 1 311 D. Look familiar? It's the VI command. It's like, do you remember DD deletes a line? Yeah, it's all starting to make sense. It's all starting to come together. mobi c.txt. And this is going to get rid of our line numbered file. Or this is not going to delete it from the original. This is going to delete it from the one we added line numbers to, remember? Number C. Well, it's not going to edit the file. It's just going to start at 311. So I can send that back out to mobi10c.txt. And now mobi10c, I've deleted it. I've deleted it all. It's all gone. What happened? It's all gone. Everything is gone. Okay. So what just happened was when we ran this command, it opened the file for writing before it read it in for reading. See what I mean about things being really dangerous sometimes? So we'll pretend that was on purpose. We'll do B into C. Now this is going to give us a file that does not have line numbers, but that maybe makes sense because now line 1 is Moby Dick or the Whale by Herman Melville. And we don't have all the Project Gutenberg stuff at the end. And then at the very end it says, end of this Project Gutenberg e-text Moby Dick by Herman Melville. So we could delete the very last line if we wanted, but there you go. Another problem that we have with our C file is that we still have Ishmael's name replaced with Roger. So Roger's in here quite a few times, 19 times in all, if I remember correctly. So maybe we want to fix that. So we could do sed s/Roger Ishmael /G less. And so call me Ishmael. Some years ago, never mind how long, everything has been replaced. The damage is done. Ishmael is no longer Roger, and we could send that output back into another file, save it for later, whatever we want to do. Now there's one other thing that I want to show you with this, which is anchors, and we can do this with VI just as easily, and I think it's a little easier in VI. So anchors can be used to give you positional information. Okay, so we've got the word coffin here at the beginning of a line. If I go to the top here and we search for caret coffin, this will find the word coffin only when it appears at the beginning of a line. That's what the caret means. Shift 6. Similarly, if we want to search for roundness, but only at the end of a line, we add a $sign. And so this is the only time roundness appears at the end of the line. Maybe axis would work. Okay, there's axis, and then do axis $sign. And then there, at the very end of the file, we can see that axis, and that's the only occurrence of axis at the end of a line. So there are other ways to do positional information. Now remember we did \D for the years. You could also do it another way, and that's with the brackets. So 0 through 9, maybe we only want to search, so that'll find 1671. Maybe we only want to do 2 through 9, so less than 2,000 square feet. So we found a 4-digit number in the file that is not a year. It's the only one. It's the only time that a 4-digit number occurs in Moby Dick that starts with a 2 or greater, because we searched for 2 through 9 \D, which is any digit. \D is just shorthand for 0 through 9 in brackets. Neat, huh? Are there any files in this line that begin with a digit? There's one, at least one, 2, 3, 4. Are there any lines in this file that begin with that don't begin with a letter? So maybe we would do beginning of the line, positional information, bracket A through Z. So that'll show us anything that begins with an A through Z. But in this context, inside the brackets, it's going to invert the match. So that found capital E. So we're going to do slash beginning of the line, invert A through Z, A through Z. That'll find a line that begins not with A through Z or capital A through Z. So that line begins with that line began with an open parentheses. This line begins with a quote, 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 another quote, a lot of quotation marks, a dash, the quotation mark. So there's quite a few lines in this book that begin not with a number or a letter. It's good to know. Maybe we want to find something at the lines that begin with like first, second, third, something like that, but with the numbers. So maybe we'll search for bracket 0 through 9, and then bracket in, let's see, first ST, second 2 ND, 3 RD, TH, 6th, 7th, 8th, 9th, 10th, 13th. Okay. So there's first Nantucket Sailor. All right. Then second Nantucket Sailor, fourth Nantucket Sailor, fifth Nantucket Sailor, first, second, third, fourth, fifth. So those are the lines that begin with first, fourth, fifth, sixth, something like that. You can also do something really, really a lot of fun. You can search for things that are formatted like a social security number, for example, by searching for 3 digits, any 3 digits, a dash, 2 digits, a dash, and then any 3 digits. And regular expressions will help you find things like that. Or things formatted like a phone number. 3 digits, 4 digits, at least in the case of a US phone number. Your local phone number situation may vary. These are the kinds of things that are likely to come up on your Linux certification test, looking for things that match these kinds of patterns.